Hi all, welcome to the session on irrational numbers. I hope you have gone through the previous sessions which is based on rational numbers, but still I want to reiterate few important points in this video. So as we discussed in the previous video, rational numbers are nothing but finite decimal numbers and also infinite but recurring decimal numbers. Finite decimal numbers, for a few examples as I have given already, 1.5, 4.2, 3.1 and etc. Similarly, infinite or non-terminating but recurring decimal numbers, as we discussed, 1.333 infinite times, where 3 the value after point or decimal is 3 and 3 is repeating, and there is a pattern like 3 is repeating infinite times. So these two conditions, if we are leaving these two conditions, then we are getting one more condition which is called infinite non-recurring decimal numbers. As you can see in the video, in the point 2, I have mentioned irrational numbers are nothing but the numbers which are infinite non-recurring decimal numbers, right? We'll see a few examples which are all infinite non-recurring decimal numbers. So what do you mean by that one, infinite non-recurring decimal numbers? We have already discussed that rational numbers can be defined in the form of P by Q. That means in the form of numerator divided by denominator, where numerator is P and denominator is Q. So logically speaking, the irrational number will be just opposite of the rational numbers, or we can say that it cannot be expressed in the form of P by Q, where P is equal to numerator and Q is equal to denominator. Let's see a few examples so that it will be more clear. As you can see in this example, the point number 4, I have mentioned 1.234561729103442 and etc. It is moving infinite time. So let me know, are you able to see any kind of pattern after decimal, like any particular value or any particular integer or any particular number which is continuously repeating? No, definitely not. You can see 2, 3, 4, 5, 6, all are different digits after decimal. So this 1.23456 and dot, we cannot define this one in the form of P by Q. So that's why it is called irrational numbers. Can you define it in terms of some numerator divided by denominator to a specific denominator value? Can you define it? No. Similarly, in the everyday life, we use, in day-to-day mathematics, we use few irrational numbers in very frequently. Those are some, for examples are root 3, root 2, root 5, as you see in the point number 4, then root 7, pi, e, all this. I know the doubt here is, we normally take the value of pi as 3.141 and the value of e is equal to 2.71. We normally take it like that. But do you really think that that is the final value of 3.141? No, we are rounding off the decimal values from, it is an infinite value after decimal. Okay, if you calculate, pi is nothing but 22 divided by 7. Okay, and here that after decimal there is no pattern and it will be an infinite value. So what we are doing, we are just rounding off to 141. So 3.141. You can calculate, try to calculate it, then you will get the value. Similarly, e is also having infinite value after decimal, but we are rounding it off to 0.7. So all these numbers, whichever it is described above, cannot be expressed in the form of P by Q. Okay. So there is a important properties based on for irrational numbers. You can see in the point number 5 I have mentioned irrational numbers, once found, it will remain till the end. What does it mean? That means, suppose while solving any question, we are finding a value as root 3 plus something. That means our answer should have option with root 3. What does it mean? Let's have look into one example. If I'll ask what is the area of equilateral triangle, you can see this is what is the area of equilateral triangle with side as 3. It is very easy question. As we all know, the area of equilateral triangle is root 3 by 4 into side square. That is fine. But suppose, think for a while that we forgot the formula itself. That means we don't know about root 3 by 4 is square or side square is the formula of equilateral triangle. But we just know that there is a root 3 term in the area formula. And then how to solve that one? Look into the option. In the option I have given 4 options. One is 15 by 4, 10 by 4, third option is 9 by 4, and fourth one is 9 root 3 by 4. So directly I can say my answer is fourth option. Why? Because as I know, and already I have discussed, that I know the formula for equilateral triangle area includes root 3. So my answer should have root 3. And out of these 4 options, only fourth option has root 3 in the output. Hence I should take 9 root 3 by 4 as my answer. That is what it is mentioned in the 5th point, that an irrational number once found, it will remain till the end of the solution. So this is all about irrational number. Once again, as we have discussed, rational numbers are nothing but finite decimal numbers, as well as infinite but recurring decimal numbers, and irrational numbers are infinite non-recurring decimal numbers. Rational numbers can be described in the form of p by q, whereas irrational numbers cannot be described in the form of p by q, or we cannot find the specific or definite value of the denominator. Hence we cannot represent irrational numbers in terms of p by q. I hope you got the point about rational and irrational. Keep watching further videos to understand different categories of number system. We'll solve many problems. Thanks a lot for joining. Thank you very much. Keep watching and happy learning. Have a good day. Thanks.